In this video, I want to show how to solve a trigonometric equation such as cosx equals to c. So let's see this on the example of cosx equals -1/2. So the first step is to draw the unit circle, and then since cos x is a horizontal coordinate, find where c is on x-axis. In this case, c is -1/2, so here is x equals to c. So then draw the vertical line x equals to -1/2. That completes the first step. The second step is find the points of intersection of this vertical line with the unit circle. There are 2 points. Let's call them P1 and P2. These 2 points correspond to 2 different angles. Let's call them x, x1, and the angle x2. And then we have to determine the angles, these 2 angles, x1 and x2. So first what we notice is that x2 is equal to -x1. So if we know one of them, we will find the other. Next, what we notice is that this -1/2 is a very special value for which we know what the point is. So the point P1 is cos of x1 comma sine of x1, and we know that cos of x1 is -1/2. And we know that this is a special value. By comparing to a reference angle in the first quadrant, we find that this is just a reflection of the 60-degree angle. So we will have that P1 is actually the point corresponding to the 120-degree angle, which is in radians 2 pi over 3. So that tells me that x1 is equal to 2 pi over 3 and x2 is equal to -x1, which is -2 pi over 3. Those are the 2 solutions that come from the unit circle. Now, of course, we have to add all the other solutions that we obtain by adding a number of full circles to either one of those. So we have to add extra solutions. Therefore, solutions are 2 pi over 3 plus any integer number of full circles, and -2 pi over 3 plus 2 pi times n, where n is an integer, and we notice in mathematics as n belongs to the to z, to the set of integers. Okay, so what if this value here was not a special value? In that case, we would apply this alternative way of finding this. What we would do, we would say x is equal to arc cos of -1/2. We would plug this in the calculator, and we would obtain 2 pi over 3 radians as the answer to this. And then we would look at the unit circle, and we would see that just as before, there are 2 solutions to this problem, one of which we have found in the calculator. That's the x, which is the x1. Then, looking at the unit circle, we find the other solution. The other solution is x2 equals -x1, which is -2 pi over 3, and just as before, just as before, we have infinitely many solutions.